Hello, math students. Welcome back to Module 2. This is Arithmetic Operations, including Division of Fractions, and this is Lesson 2, and it is called Interpreting Division of a Fraction by a Whole Number. Interpreting division of a fraction by a whole number. The goal for today. Today we will divide fractions by whole numbers using visual models. The question that I want you to be thinking about is, when you divide a fraction by a whole number, how does the quotient compare with the original fraction? All right, some things to know. First off, we have to be very, very clear of what a fraction is. A fraction is a number that represents a part of a whole. For example, this is a fraction. The part of the whole consists of 8 sections, and 5 is what you actually have. So 5 is the numerator, 8 is the denominator. Okay, so we would know this one right here is the denominator. Okay, and this one right here is the numerator. Hopefully this is not the first time you're learning this. Hopefully you've learned this before. So a denominator is the quantity that tells you how many parts the whole is divided into. And so our example of that is, this is what the fraction of the whole would look like. It means it has 8 sections that create one whole piece. And so we know that in order for it to be a whole piece, there must be 8 sections there. The numerator is the quantity that tells how many pieces the denominator are available. So for example, this is the exact same whole up here because there's 8 pieces, but the numerator tells us what is available. Okay, so we only have 5 out of the 8 pieces available. And usually the way that works in drawings is the pieces that are available are actually colored in. So on this model right here, we can color in 5 of the pieces because that's out of the whole, that is what we have available. And so it's very, very important to remember that the shaded amount represents the numerator, or what we have. Okay? So then the next thing that we need to talk about is sharing the love. It's an example of what we're actually going to do, because remember, our goal was today we will divide fractions by whole numbers using visual models. So this says, we love pizza at our house. There is half of a pizza left, and there are 5 people in my family. So the question that I want to ask is, how much of the pizza will each person get? And so if you remember in our previous lesson, we're going to ask the question, how many pieces of pizza will each person get when we only have a half? So the amount that we have is a half, and then the number of people that need to eat it are 5. So we can do this by looking at a tape diagram. So this is the whole, right? This is the whole pizza. But the only part that we have available for the whole pizza is this half of it, okay? And so if there's 5 people that want some of this, if you think logically about it, well, the person with the pizza cutter is just going to cut it into 5 equal pieces, okay? And so what we have to think about is we have a half, and we need to divide it into 5 equal pieces. Now, in order to have 5 equal pieces, we have to remember that this used to be a whole pizza. So if you're going to cut something, you're going to cut it equally. And so in order to get 5 equal pieces, we would have to go 1, 2, 3, 4, 5. Now those don't look super equal, and I'm very sorry for that. But what we also have to remember is what you do to one side, you have to do to the other. So even though it doesn't exist and it's not there anymore because we already ate it, we still mathematically have to remember it, because there's that rule in math that you always have to do what you do to one side, you have to do to the other. So this, remember, was a whole pizza. Well, only half of it was left, and we need to have enough for each person, and there are 5 of us. But remember, in math, what you do to one side, you have to do to the other. So now you have to look at this and say, okay, what would each person get? And so each person is actually going to get 1, because that's for person 1 right there, for person 1, for person 2, for person 3, for person 4, person 5, And then this is what they ate yesterday, right? So actually, each person gets 1 out of the 10 pieces that would have been there. Okay? And so the thing that's crucial about this is to remember what you do to one side, you have to do the other. So even though we only had half of a piece of pizza left, we had to go ahead and make it so that there was enough for 5 people all the way across. And since we divided this half into 5, we have to divide this half into 5, and then that tells us the amount of pizza that they got was 1/10. So basically, you're taking the algorithm for this one would be 1/2 and dividing it into 5 equal pieces. Okay, 5 equal pieces. And when you do that, each person would get 1/10 of the whole pizza, because you're remembering this used to be a whole pizza, but there's only half of it left. So each person gets 1/10 of it. Okay? All right. So now let's try a couple of more and see if we can do the same thing. So it says 4/5 divided into 3 people. So again, we have 4/5. So we're going to draw our whole, right? So here's our whole, and we have to make it into fifths because that's the denominator, and it tells us how many sections each person gets. And because Mrs. Nelson can't draw today, I'm going to just cross this part out. This part doesn't exist, and I apologize for making it too big. But there's my 5 sections, right? And of those 5 sections, there's only 4/5 left. So I'm going to use a different color so you don't get confused. So here's the 4/5 that are left, right here. 4/5 that are left. And now we have to say that we're taking those 4/5 and we're sharing them between 3 people. So we could say, well, one person gets this, so this would be person 1, because that's an equal share, right? One person would get this, so that's person 2, right? One person gets this, person 3, right? And that's an equal share, so everybody gets 1. And then how are we going to make sure that this is equal share too? Well, in order to do that, we've got to cut it into 3 equal parts. So if we do that, we're going to cut the whole thing, remember, because what we do to one side, we have to do the other. And so what we would have is we would say, this one right here is person 1, this one right here is person 2, and this one right here is person 3. And so, how many total pieces do we have? We now, instead of having only fifths, we actually have turned it into 15ths, right? And so each person would get 1 and 1/15. Okay? 1 and 1/15 is what you would see, because each person gets that many. All right? And so the way that we check it is we would say, okay, 1 whole piece is actually 1/15, right? So let's actually, I'm going to cross that out just for a minute because we need to count with what we have. So person 1, you get 1, 2, 3, and this one would be 4/15, right? And then person 2, right next to us, 1, 2, 3, and there's person 2, so that would be 4/15. And then person 3 would be 1, 2, 3, and person 3, so 4/15. And so if we're looking at it by our picture, that used to look like a whole, so I don't want to do mixed numbers anymore because we're really trying to stay away from that. Let's just represent what we see. And so person 1 has 3 here and 1 more makes 4. Person 2 has 3 here and 1 more that makes 4. And person 3 has 3 here and 1 more, which makes 4. So your answer to this problem, 4/5 divided by 5, or 4/5 divided by 3 is actually 4/15. Is the final amount that they have, because we took that whole apart and broke it into the 15ths that they see. Okay, so try not to get too confused with this. I think the more we practice with it, the easier it will become. Let's do one more and see what happens. So this time it says we have 2/7, so I'll try to be careful with my drawing so I don't draw any extra this time. And so we were going to say this is 1, 2, 3, here's 4, here's 5, here's 6, and 7. Yes, I did it very well this time. All right, so now let's again color in what we have. We unfortunately, if this was a Snickers bar, we only have this much left, okay? And this time we have to divide it so that there are enough for 9 kids to have it. Wow, that's kind of scary. So what I would say we do is let's just take this and we would cut it so that each kid gets their equal share, and that means that I'm going to have to fit 9 pieces in there so that we can each get their equal share, right? So how many is that? 1, 2, 3, 4, 5, 6, 7. We'll just cheat a little bit and make it a little bit bigger. And say that this now represents the 9 equal pieces, right? So color those guys in as part of the 2/7 that was there. And now, so this one right here would be person 1. This one right here would be person 2, person 3, person 4, person 5, person 6, person 7, person 8, and person 9, right? And then what did they actually get? Well, as you can tell, when we had to divide it into 9 equal parts, we went from having just sevenths into, well, there's 9 here, so 9, 9, 9, 9, 9, 9, 9, which actually becomes 63, right? 63 pieces. And then what do they get out of it? Each person only gets 2 63rds, right? 2 63rds. So that answer would be one person got 2 63rds, the next person got 2 63rds, the next person got 2 63rds. So the answer to this problem, 2/7 divided by 9, is actually 2 63rds. Okay? And so as long as you can remember that when you're taking a fraction of what you have and dividing it by a number of people, that they each have to have their equal share or a fair share of it. And so that's how you have to split it up so they all get an equal amount. Okay, so going back to what we started with, today we will divide fractions by whole numbers using visual models. Basically, the fraction represents what you've got. The whole number is representing how many people need it, okay? So it's very important to keep that straight. So you draw what you have, and then you have to divide it into equal shares for all of the people that are trying to get it. And I always try to remember it that way because you have a stack of, or you have a piece of whole chocolate cake, and you have to split it up so every person gets an equal share or a fair share of it. All right, question. When you divide a fraction by a whole number, how does the quotient compare to the original fraction? Well, let's look at that. How does the quotient? Remember, quotient is the answer. So what does this fraction look like compared to what we started with? We started with a half, and we ended with a tenth. We started with 4/5, and we ended with 4/15. We started with 2/7, and we ended with 2 63rds. And so the answer to that question, when you divide a fraction by a whole number, how does the quotient compare to the original fraction? I would say the quotient is always smaller than the original fraction. All right? Okay, kiddos, that's all I have for you in this lesson. I'll talk to you soon. Bye!